Orkestra is a unique software suite for building public or private clouds on open hardware platforms. MPSTOR integrates in a single product scale-out automated provisioning of storage, compute and networking using its three standalone software modules: Orkestra-SAM for storage array management, Orkestra-SDS for scale-out of automated provisioning, and Orkestra-IaaS for building public or private clouds. Key to satisfying cloud users are applications that work as expected. Applications that work as expected need appropriate storage capacity and performance. So whether your application is CAD or video streaming, data analytics or product management, all of these applications occupy a position in the grid of performance versus capacity plane. Operators need to provide self-service dashboards that can provision capacity and performance but mask the user from data center complexity. Orkestra-enabled end-user dashboards with automated provisioning of compute and storage allow the operator to deliver the infrastructure for applications to work properly. SDS toolsets allow the operator to mask the complex data center provisioning. Not all users are the same, and some users need more control of provisioning and policies. Orkestra VSA software allows each user to launch in his own tenant space his own virtualized, full-featured storage array. MPSTOR's Orkestra product meets the challenges of delivering differentiated solutions at scale cost-effectively by the automated provisioning of storage, compute, and networking. Operators have several options in building a cloud. They can buy and integrate proprietary appliances. They can develop in-house using open platforms, but both of these solutions have high costs. The Orkestra solution, fully integrated on hardware platforms and using a mix of proprietary and OpenStack components, is the most cost-effective solution. Orkestra's features and benefits include low capex and scalability, low opex, differentiated product offering, flexible and future-proofed framework for service creation, end-user-driven dashboards with the SLA QoS tiers, scale-out and scale-up of compute and storage that are all better utilized and managed and resilient to component failure. Using Orkestra, building flexible, scalable data center services is simple and inexpensive, with benefits such as addressing the challenging price points of cloud service economics, providing flexible provisioning to cover a wide range of cloud SLA and use cases, and managing the many consumer and provider types within the data center. Challenge number 1 is how to build a flexible, scalable data center cloud service simply and cost effectively. Orkestra is composed of 3 independent modules: Orkestra-SAM for storage hardware management, Orkestra-SDS for automation and virtualization, and Orkestra-IaaS for all of the end-user compute and storage and networking services. The Orkestra model for building a public or private cloud starts by identifying the consumer and providers and the tools required to allocate storage from providers and attach that storage to the consumers. Orkestra provides a complete integrated software suite to enable this. The Orkestra modules are standalone or integrated together in the Orkestra-IaaS solution. Storage providers deliver storage as either block, file, or object. Orkestra also provides storage offload processing used in many data analytics frameworks. In addition to the features provided by the storage array layer, Orkestra has a unique in-band service layer. This layer terminates storage array volumes on the south side interface and attaches storage to the consumer on the north side interface. The VBS layer provides a range of services such as fabric management, data protection, and extra resiliency such as multipathing and array striping. Orkestra delivers resources to the data center consumers, physical nodes, storage-centric services, virtual machines, and entire tenant spaces using a range of different modules. The Orkestra VSA, which provisions a complete tenant space, Orkestra-SDS, which is used with either OpenStack or VMware to provision automated storage to the virtual machines, and Orkestra-SAM used to transform bare metal servers into full-featured storage arrays. When used together, these modules form the Orkestra-IaaS solution, delivering scale-out compute and storage through managed, resilient storage over multiple fabrics at configurable SLAs and policies. Installing, configuring and operating the cloud are simply done with the Orkestra Automated Provisioning Layer and Operations Toolset. The second challenge we're going to look at is the CapEx and OpEx of operating utility cloud. Orkestra-SAM is the basic building block of Orkestra. It turns bare metal hardware into full-featured storage arrays, managing disks and providing block, file and object storage. Orkestra-SAM is designed for open storage platforms which reduce CapEx, with additional benefits of scalability, flexibility and a complete enterprise feature set. Installing any Orkestra module is easy. Download the Orkestra package from the MPSTOR website, use the installer to create a bootable USB key, configure a management IP address and log into the system. Once installed, the system shows which components and revisions are enabled. Setup tools allow the user to configure the system for remote access, IP configuration, time and NTP servers, SMTP email for alerting, and license setup for installing licenses after the trial period has expired. Core to Orkestra-SAM is the management of disks, locally attached disks or remote disks. For local disks, we can view where a disk is located, view which RAID is using a disk, and the disk state using its smart data. Orkestra-SAM renders a complete graphical front and back view of the enclosure, showing which disks are installed where. The back view shows the enclosure fan, temperature, current and voltage status. Many different renderings have been implemented, such as high density storage, server storage and SSD storage. IOC management allows IOC controllers to be configured, such as Fibre Channel, Ethernet or SAS IOC controllers. Port modes such as target or initiator can be configured, as well as the port width and port speeds. Ethernet channels can be bonded together and the bonding strategy selected. RAID management provides storage redundancy. The RAID configuration can be controlled by setting the RAID QoS, the RAID levels, the write caching policy and the read ahead policy, and finally which controller should home the RAID in a multi-controller H8 configuration. Volume management is one of the more complicated tasks in storage management. Adding a volume requires 5 steps. The first step is to choose the properties of the volume, such as its size, LUN number, thin provisioning. The write caching policy can be set to safe, write back or mirrored cache in dual controller configurations. Throttling can be set on IOs per second or megabytes per second. The second step is to choose which RAID to build the volume on. A volume can be built across multiple RAIDs or on a single RAID, as long as the RAID QoS is compatible with the volume QoS. Step 3 is to configure the thin provisioning. Step 4 is to choose which fabric the volume will be exported on, such as Fibre Channel or SAS or Ethernet, and which protocol such as block or CIFS or NFS to use. The last step is to choose which host or host machines will have access to the volume. Snapshots are a convenient way to keep point-in-time copies of volumes. The snapshot properties can be configured, such as the retention policy, which allows snapshots to be kept forever or for a finite time period. Snapshots are implemented as copy on write. Therefore, we need to allocate from existing RAID storage a buffer big enough to accommodate all the changes to the snapshot. Unlike many snapshot strategies, MPSTOR allows the snapshot buffer to overfill, and when it hits a configurable threshold, 90% in this example, it will re-provision additional storage. Snapshots can be made continuously by creating a schedule with a start time, end time, and frequency. Replication allows a source volume to be replicated to a destination volume. Replication works by noting which LBA addresses have been written to and then copying them to the remote volume. Replication is easily configured by selecting a source volume and then a destination volume, and the destination volume can be on the same machine or on a remote machine. Cloud backup allows a volume to be backed up to an object store. A number of object stores are supported, such as Amazon S3, Rackspace, and EMC Atmos. Choose the backup parameters such as the object store type and access credentials, as well as compression and encryption options. Next, choose the volume to be backed up, and finally the schedule at which the backup will occur. Orkestra-SAM also provides comprehensive logging of all operations to the storage nodes, as well as I/O stats to disks, RAIDs, and I/O ports. Statistics are kept on I/Os, errors, and SCSI failures. Over time, components fail. Orkestra keeps timestamps for all the critical physical and logical elements of the array. Should an error or failure occur, the alert management feature will send an email on any one of three types of event: information events, warning events such as a degraded RAID, and critical events such as a dead or failed logical or physical component. Challenge number 3 is the many use cases and SLA requirements within the cloud require software flexibility. We've just seen how Orkestra-SAM can transform a bare metal server into a full-featured storage array, allowing storage to be easily added to the data center. Building storage based on bare metal commodity hardware is a great way to reduce CapEx costs. Orkestra-SAM has a rich API that can be managed from the Orkestra-SDS controller. Combining Orkestra-SAM with Orkestra-SDS is a great way to reduce OpEx expenditure, as all provisioning requests from the Cloud OS are made automatically by the SDS controller. Orkestra-SDS provides automated provisioning, scale out of compute and storage into configurable storage and compute pools according to operator control policies, and Orkestra-SDS manages all of this across multiple fabric types. Consider the issues surrounding provisioning. How hard actually can it be? Considering a simple configuration of 10 storage nodes providing storage from one storage tier using one protocol, saying object or iSCSI storage, across one fabric to 10 storage nodes. The number of options is around 100. It's not a difficult problem, but we are very limited in what choice we can offer the end user. In other words, if the system is not flexible and has very little user choice, provisioning is not difficult. If we now consider the same configuration of 10 storage nodes providing storage from 3 storage tiers, say SSD, 15K drives and cheap SATA drives, using various RAID levels depending on resilience required over block or object storage in single or dual controller configurations across multiple fabrics such as 5 or GigE or 10 GigE to the same 10 different nodes. The number of options is around 16,000, and it climbs to 250,000 when all the options of thin provisioning, snapshot, replication and cloud backup are included. This is not easy, as any sysadmin will tell you. So provisioning with options is not too easy if you provide user choice. Orkestra-SDS provides tools which allow the cloud logical world to be mapped to the physical world. Orkestra-SDS allows the cloud provider to adopt a strategy which provides user choice, differentiation and flexibility that is driven by automated provision directly from the end user dashboard. This is key to the OpEx savings that Orkestra-SDS delivers to a cloud provider. Orkestra-SDS can be configured to provide a range of SLAs at different capacity points, which allows the end user applications to work correctly. An example configuration of Orkestra could be a data center offering compute in 3 different groups such as gold, silver and bronze, and storage groups such as basic, standard and premium, with each storage group mapped across different fabrics to storage assets with policies for how the storage should be managed. Rules can also be created that map each compute group to different storage groups. In this configuration, SDS now automates the provisioning of storage per group, and each group has a configurable QoS and SLA. Using the Orkestra toolset, this configuration can be easily built in a number of steps. First of all, create a policy describing how the storage is to be managed. Then create a compute group container. And finally, a storage group container associated with the storage management policy. Having created our group containers, we need to populate them with storage nodes that have been auto-discovered by Orkestra. Simply select a node and click on the link to add that storage node into the storage group, or unlink to remove it from the storage group. And likewise for compute nodes, using the link and unlink to remove them from a compute group. For nodes that have not been automatically discovered, a tool allows manual configuration of the storage IP address. Orkestra contains a lot of configuration data and operational time series data. Orkestra tools can browse this database through a single pane of management using different views of the CMDB database. Systems can be monitored, faults isolated, and repaired. Provisioning storage from a pool to a data center node is simply done. Create the storage volume, select the node to attach it to, and the volume is now available on the node and is managed according to the policy for that group. This complex operation is achieved with no admin overhead. When a provisioning request is received, Orkestra-SDS, using its knowledge of the cloud topology fabric node, selects a storage provider, and a volume is created. Based on the group policy, the storage array volume is exported to the appropriate fabric and attached to the consumer node, and the appropriate service stack is built. Finally, the volume is attached to the consumer. All of these steps were accomplished without the need of an administrator. Orkestra also provides tools to monitor and track usage of resources, as well as monitoring and alerts of the cloud logical and physical elements. The final challenge is managing the many different consumer types and provider types which require a complete integrated solution. Orkestra-IAS, built with OpenStack, is a scalable, flexible, and resilient to failure data center solution. Orkestra-IAS turns commodity hardware into complete public or private clouds. Orkestra-IAS is a turnkey, ready-to-go solution. Orkestra-IAS setup is GUI-driven and requires little or no knowledge of OpenStack or any Linux command lines. Simply configure the services you wish to run on any particular node, such as Cloud Controller, Storage or Compute, or for an all-in-one configuration, choose everything to run on the same node. Once the cloud is configured and running, Orkestra-IAS provides the operator with detailed logs to ensure that the cloud operates correctly, as well as tools to manage the services individually. When our cloud users now access their Horizon dashboards, they see two important extensions to the standard dashboard. The first is in the volume section, where the Orkestra-SDS volume groups will be displayed for all provisioned volumes. Volume Create tab. During a volume creation, the storage group can be chosen from the list of configured storage groups. In Compute, the compute groups are displayed per virtual machine, and when launching a virtual machine, the user can choose his compute group within which he wants to launch the virtual machine. Orkestra provides the tools to create easily within the data center pools of scalable compute and storage at various QoS and SLA levels that match the end user requirements over a wide range of use cases. Many of these users are content to use the end user cloud dashboard, which masks the data center complexity through automation of resources in compute and storage groups. The final class of users are those who require more control of their storage policies. Orkestra provides these users with a virtual machine image to manage storage within their own tenant space. This is the Orkestra VSA image, which allows the user full control of the storage management and control policies. Orkestra is an integrated suite of software modules that allows an operator to build on bare metal servers a flexible, scalable, full-featured cloud easily and cost-effectively that delivers the user choice so that user applications will work as expected in a cost-effective way.